In addition to the trigonometric ratios sine, cosine, and tangent, there are three other trigonometric ratios called cosecant, secant, and cotangent. These ratios are the reciprocals of sine, cosine, and tangent. Sine, opposite over hypotenuse, the reciprocal. Cosecant, hypotenuse over opposite. Cosine, adjacent over hypotenuse, reciprocal. Secant, hypotenuse over adjacent. Tangent, opposite over adjacent, reciprocal. Cotangent, adjacent over opposite. Example 1. Find the values of 6 trigonometric ratios for angle P. Okay, so first of all, we identify the angle, which is angle P right here. All right. Now, as you notice, we have a right triangle. We have the legs, but we have a side missing. Therefore, our first step will be using the Pythagorean theorem to find the missing side. Now, as you can tell, this is the longest side, which is the hypotenuse. In the Pythagorean theorem, it's known as C. So we use a squared plus b squared equals c squared. We could say either 7 or 10 can be used as a or b. Let's say 7 squared plus 10 squared equal c squared. Now, 7 times 7 is 7 squared. 7 times 7 is 49. So 49 plus 10 squared is 100 equals c squared. 49 plus 100 is 149. The opposite of squaring a variable or a number is taking the square root. So we take the square root of 149. Now, usually we break down square roots where we find the decimal, all right? In this case, 149 can't be broken down. So we're just gonna leave it as the square root of 149. The next step is to identify the parts of this right triangle. All right, so since we're dealing with angle P, we take our pencils and we drew a line straight across, then we will hit 7, which is the opposite. We know that the longest side is the hypotenuse, which is right here, so that would be square root of 149. So that leaves 10 as being the adjacent. All right, from this point, all right, we find our trig functions. So we start off with the sine of P equals opposite over hypotenuse, The radical can't be in the denominator, all right? So we multiply, so your answer is 7 square root of 149 over 149. Next, we have the cosine. cosine of P is adjacent over hypotenuse. So that would be 10 over square root of 149. All right? We know what we have to do to this part, so we don't have to write that all over again. We can just say 10 square root of 149 over 149. Next we have tangent. All right, and the tan is opposite over adjacent. Opposite is 7, adjacent is 10. 7 over 10. Next we have cosecant. All right, so we know that cosecant is reciprocal of the sine, so we take the sine from this point. All right, so basically the cosecant will be the square root of 149 over 7. We have the secant of P, which equals the square root of 149 over 10 Then we have the cotangent of P, which equals 10 over 7. Find the values of the 6 trigonometric ratios for angle E. All right, first of all, let's take a look at angle E. We have angle E right here, all right? So that's what we have to find the 6 trig ratios for, that angle. So off top, we know that we're missing the side. We have the hypotenuse this time, we have one of the legs. So what we have to do is find this missing side, right? So once again, we use the Pythagorean theorem. This time we have the hypotenuse, all right? The hypotenuse in the Pythagorean theorem is always known as C. So this time we're going to say 3 squared plus, we're missing the side, so we're just going to say b squared equal square root of 58 squared. 3 squared is 9. The square root of 58 squared, all right, whenever you square a square root, we get what's under the radical, all right? So if we squared the square root of 58, the answer would be 58. Next, one-step equation, we subtract 9, b squared equals 49. Whenever we have a variable squared, we take the square root of the number. Square root of 49 is 7, so b equals 7. Missing side is 7. Next, we identify the components of this right triangle. We know that this is the hypotenuse. Since we're dealing with angle E, 3 is the opposite, and 7 adjacent. Therefore, sine of angle E equals opposite over hypotenuse, which is 3 over the square root of 58. We know that the radical cannot be in the denominator. So our answer will be 3 square root of 58 over 58. Cosine. Adjacent over hypotenuse. 7 over the square root of 58. All right, we know that the radical can't be in the denominator. 7 square root of 58 over 58. Tangent. Opposite over adjacent. Three over 7. Cosecant. All right, cosecant is the reciprocal of sine. So right here, we start from this point, square root of 58 over 3. Secant all right, is the reciprocal of cosine. So right here is the square root of 58 over 7. And then we have cotangent. Reciprocal of tan, 7 over 3.